Hi everybody, this is Mr. Rocco, and today we're going to be working on our Minerals e-text reading assignment. In this assignment, we're going to be investigating what the characteristics and properties of minerals are. In class before spring break, we looked at some different properties that minerals have, and we completed a gizmo lab where we explored things such as the color of the mineral, the luster of the mineral, the streak of the mineral, the hardness of the mineral, and the crystal shape. So we're going to be exploring how do we differentiate one mineral from another. We're going to look at, well, what are the processes that result in the formation of minerals? So how do minerals form? And what processes explain the distribution of mineral resources on the Earth? So why do we find minerals in certain places on the Earth and in other places we don't? Some of our vocabulary words are going to be mineral, crystal, and crystallization. So the very first part of this reading, you want to take a look at the picture in the background. And in this picture, you can see that there is a scientist, an explorer. They're wearing a suit and they're exploring a cave, and this is actually a real place and a real picture. And you can see there are some very large crystals that have grown there. This is actually in Mexico, just south of the United States, where this cave is. And it says, do you think these crystals formed in conditions that were stable or that changed often? So I want you to first reflect on this question. About what do you think the conditions were like where these crystals formed? Do you think the conditions were very constant? Like maybe the temperature was very constant, the amount of water was very constant, or were the conditions changing over time? So you might say something like, I think the conditions in this cave were constant because, or maybe you think they weren't constant. What do you think would have to happen for these large mineral crystals to form, like you can see here? All right, then we're going to be reading about what a mineral is. So basically, a mineral comes down to the following things. A mineral is going to be something that is naturally occurring. So they're formed through natural processes. All minerals are solids. They form through an inorganic process. So they're part of non-living things. They all have a crystal structure or a shape to them. And they have a definite chemical composition, which means that they're made up of a specific chemical formula. All right, on this next page, you're going to be looking at the different mineral properties. We spent a little bit of time with this before spring break when we were working on the Gizmo identification lab. But the main mineral properties that we use to determine one mineral from another are shown on this page. So we have the streak, the color, and the luster. And then what you want to do as you're reading, you want to complete figure 2 here. And it says you can identify a mineral such as pyrite by its properties. Describe the color and luster of pyrite. So this mineral that we're looking at right here, this is actually the mineral pyrite. And what they want you to do is to describe the color and the luster. So you want to go ahead and fill out that graphic organizer there to practice identifying minerals by using some of their properties. And then if you look at the table, you can see the other properties of the mineral pyrite. If you go to the next page here, this is the other part of the side of the page. This is the mineral pyrite again. And we have some other mineral properties that we're going to be reading about, such as density, fracture, crystal structure, and special properties. So all of these are properties that every mineral has that make them unique from each other that we can use to help identify them. Also, hardness is also a very important property. You guys do not need to do the math toolbox. You can cross that off. On this page, we're going to be reading about where do minerals form. So you want to study figure 3, and it says minerals form by crystallizations of magma and lava or by precipitation of materials dissolved in water. Circle the area where you might find a cave with crystals similar to large crystals shown. So when we looked at this picture here, where we saw these large crystals forming inside a cave, I want you to look at the figure 3 here and circle an area on it, on this page, where you think there might be a cave that could form where water breaks down the rock and forms a cave where these large crystals could form. So we obviously, you would have to, in this area right here, this would probably be not the best area because that's kind of a beachy area. There's really no layer of rock or anything like that. And if we go over here, kind of in this area, you can see we have layers of rock, and you could imagine that water could trickle down out of these hills, and it could sink into the rock and break the rock over time and form caves, possibly. And it looks like we also have a cave kind of down in this area already, too. Okay. All right, then you're going to be reading about mineral formation, so what processes occur to form minerals. So we're looking at organic minerals and how minerals form out of solution. So this is one way that many minerals form is when minerals are dissolved in a liquid like water. When that water evaporates, those minerals are left behind and they can form into a solid crystal shape. You do not need to do the academic vocabulary. On this page, this is showing some other areas and locations where minerals can form. If you look at the literary connection here, it says, underline the name of each mineral mentioned on this page, then record each mineral in its correct place. So if we go in here and read about minerals from magma and lava, it says many minerals form when hot magma from Earth's interior cools higher up in the crust as lava cools and hardens on the surface. When these liquids cool to a solid state, they form crystals. The size of the crystals depends on several factors, including the rate at which the melted rock cools. Slow cooling leads to the formation of large crystals such as quartz and feldspar crystals. So what they wanted us to do was to underline any of the names of the minerals that can form. So we have quartz, that's one. We have feldspar, and it says they cool pretty slowly. So we're going to come up here, and it tells us that they form from magma and lava. And it talks about how the size of the crystals depends on several factors, including the rate at which the melted rock cools. Slow cooling leads to the formation of large crystals such as quartz, and feldspar crystals. These crystals are found in granite that slowly cools underground. Alright, so since these are cooling slowly, we would assume that quartz and feldspar would be forming deep in the earth, where the temperatures are still very warm, and where the mineral crystals would have lots of time to grow, so they'd be very large. So what we want to do is we want to write down the names of some of the minerals and where they form. So we have quartz and feldspar. So you want to make sure you continue to read through this page and label what minerals, the names of the minerals that would form in the places that are shown in these boxes. Then you have a reading check right here. It says summarize the text. What types of minerals might a geologist expect to find near the site of an ancient lava flow? So the hint here is a lava flow happens on the surface of the earth. So what kinds of minerals would you find when lava cools? So if you read this page, you'll find that. Alright, on this page, you're reading about how minerals can be changed, and they give the example of how a diamond forms. So in figure 4, it says a ring from a pencil. Figure 4, immense pressure and heat in Earth's mantle compacts graphite into diamond. Why do diamonds only form in certain spots in the mantle? So you want to read through this page and read about the formation of a diamond, and then you can answer that question here for figure 4. After you read about the formation of a diamond, we're going to create a model to show the formation of a diamond. So it says, use the information in the text in figure 3 to draw a diagram that shows how diamonds form. Your model should show and label the following parts. It should show graphite in the mantle under intense pressure. It should show in the past that magma from the mantle moves quickly towards the Earth's surface, forming pipes, and that the magma cools and the diamonds are trapped in it. So kind of the setup here is we have some sort of volcanic some sort of volcano going on at the surface of the Earth here, right? And then we're going to have basically underneath the Earth, we're going to have to show that there were kind of tubes, formations of lava that were kind of reaching up to the surface here like this. And then what we can show is that over time, these lava tubes cooled, and then we can put little kind of pieces of graphite in there, and then we can show that this graphite, this mineral, over time, we can show that there was much heat and pressure pushing on these minerals in all directions, and that heat and pressure alters the mineral, graphite, and can turn it into a diamond. So maybe I'll just draw some little diamonds here. And then what happens is these diamonds can get shot out of a volcano, or the volcano can erode, and we can dig into the ground and find these pipes. These are called kimberlite pipes, where graphite has been put under pressure to turn into a diamond. So I want you to create your own model to show how you think graphite can be changed into a diamond. All right, on this page we're going to be reading a little bit about where minerals are found on the Earth and where we find those and why they are in the place where they're at. So there's a reading check question here. It says integrate with visuals. What ideas from the text are illustrated in the map in figure 5? So you want to look at this map and look at the key here. And what is this map showing us? So you can see in the key we have different minerals like aluminum and copper and diamond and gold. And if you look at the map, you can see where those different colored triangles are, and we can see where minerals are typically found around the Earth. And there's some patterns that you should see. And you're doing that same thing for figure 5. It says the map shows the location of some important mineral resources. Many of the minerals represented on the map are not evenly distributed across the planet. What patterns do you notice? Okay, so for a sentence frame here, you could say the patterns I notice about mineral locations are, and you can finish that sentence. One of the patterns I'm seeing is you can see that a lot of minerals seem to be found on the edge of continents. So here's the edge of Africa, here's the edge of kind of Asia. So what does that tell us about maybe the conditions that occurred to create minerals there? Also, these are kind of the locations of mountain ranges in some of these places, okay? So there's a lot of patterns here that might give us some information about why minerals are found where they are at. So make sure you guys double check, go through this. You're completing figures 1 through 5, the reading check questions, the model it question, and the remember you're highlighting the vocab words. You're identifying which minerals are found and what process they are created through. And you're working through this reading activity. So we'll be working on this in class next week. If you aren't finished with it